The vision of humans walking on Mars, leaving their footprints on the rusty soil, has been a long-held dream. It's a symbol of our relentless pursuit of exploration, our innate desire to push the boundaries of what's possible. The idea of building cities beneath a salmon-pink sky, creating a new home away from home, is captivating. It sparks the imagination and fuels our ambition to become an interplanetary species. For generations, we've gazed at that red dot in the night sky, a beacon of mystery and potential. Mars has always been more than just a planet. It's a symbol of hope, a testament to our enduring curiosity. And we've wondered, could we live there? Could we transform this alien world into a habitable environment, a second Earth for humanity? Today, these questions are being debated in boardrooms and space agencies around the globe. Scientists, engineers, and policymakers are grappling with the challenges and opportunities that Mars presents. This isn't just the stuff of science fiction anymore. It's becoming a tangible goal, a project that could redefine our place in the universe. But the reality is daunting. Mars is not a welcoming paradise. It's a harsh and unforgiving environment. Surviving on Mars means creating an entire ecosystem from scratch, replicating the delicate balance of life that we take for granted on Earth. It means building a home in a frozen, irradiated desert, where the air is unbreathable and the soil is toxic. Inspiration drives innovation, pushing us to develop new technologies and overcome seemingly insurmountable obstacles. But it can't shield us from cosmic rays, the constant bombardment of high-energy particles that pose a significant threat to human health. Inspiration alone can't conjure breathable air in a place where the atmosphere is thin and composed mostly of carbon dioxide. Before colonizing, before building cities and establishing a permanent presence, we must first survive the journey and the harsh realities of the Martian environment. The risks are substantial. The costs, both financial and ethical, and the potential dilemmas are immense, demanding careful consideration and responsible decision-making. So, is Mars colonization truly possible? Is it a realistic goal or just a distant dream? Maybe. A small research outpost, a scientific base like Antarctica, is within reach in the near future. But a thriving, independent civilization, a self-sustaining community of thousands or even millions of people, that's a much bigger challenge, requiring breakthroughs in technology and a level of international cooperation that we've never seen before. We're only beginning to understand the hurdles that stand in our way, the scientific and engineering challenges that must be overcome. In this discussion, we'll explore the obstacles, the harsh realities of the Martian environment, and the technological limitations we face. We'll delve into the technologies that could make Mars colonization possible, from advanced rockets and life support systems to innovative construction techniques and resource utilization strategies. And we'll grapple with the ultimate question, the ethical considerations and the potential consequences of establishing a permanent human presence on another planet. It's not just a matter of whether we go to Mars, but whether we. What are the potential risks and rewards, and who gets to decide? The answer will shape humanity's future for centuries to come, influencing our values, our priorities, and our understanding of our place in the cosmos. Our fascination with Mars stretches back over a century. In the 1890s, Percival Lowell imagined Martian canals built by a dying civilization, an idea that ignited global curiosity. By 1948, Wernher von Braun envisioned a fleet of spacecraft carrying astronauts to Mars, even inventing a Martian leader called Elon. These dreams, from Lowell's canals to von Braun's flotillas, made Mars the next great frontier after the Moon. Today's Mars missions are built on this foundation of imagination and ambition. The journey from fantasy to robotic rovers shows our persistent desire to reach our planetary neighbor. Understanding this history reveals why Mars still captures our collective imagination. It's not just a technological pursuit, it's a century-old dream. Our robotic explorers have revealed Mars as a world shaped by water. Ancient lake beds and river deltas explored by rovers show Mars once had the ingredients for life. Today, vast reserves of water ice lie beneath the surface, even near the equator. If melted, this ice could cover Mars in a global ocean. Water is the key to colonization. It can provide fuel, oxygen, and of course, drinking water. But extracting and using it is a massive challenge. The thin CO2-rich atmosphere complicates everything. We need new technology to mine, melt, and purify Martian ice, none of which has been tested off Earth. The resources are there, but turning them into survival tools is one of our greatest engineering hurdles. Solving this is essential before any long-term outpost can exist. Mars is often called Earth's sibling, but don't let that fool you. It's a hostile sibling, a world of extremes, and survival starts long before you even set foot on the red soil, beginning with the arduous journey itself. The trip is fraught with peril, a true test of human endurance and technological prowess. Astronauts will face intense radiation exposure during their time in space, a constant barrage of cosmic particles. The radiation levels are equivalent to hundreds of chest X-rays worth of exposure, a significant health risk that needs careful mitigation. This is all happening without Earth's protective shield, the magnetic field, and thick atmosphere that deflect harmful radiation. On Mars, the thin atmosphere offers little protection, and the planet's lack of a global magnetic field leaves the surface vulnerable. This means constant exposure to dangerous radiation, a relentless threat to the health and well-being of any Martian colonists. Habitats may need to be buried deep underground, utilizing the Martian soil as a natural shield against radiation. Martian soil is also toxic, unfortunately, filled with perchlorates and other compounds harmful to human health. The ever-present dust, easily kicked up into massive storms, could cause serious respiratory and other health issues if inhaled. Gravity on Mars is only 38% of Earth's, a significant difference that poses its own set of challenges. And we simply don't know the long-term effects of this reduced gravity on the human body, especially over extended periods of time. We know that microgravity already causes bone and muscle loss, weakening the body over time. Mars's gravity, while better than none, could still be just as damaging in the long run, leading to similar health problems. These are not just engineering problems that can be solved with clever designs and robust materials. They're fundamentally medical and biological ones, requiring a deep understanding of how the human body adapts, or fails to adapt, to the Martian environment. Before we can even dream of building sprawling cities on Mars filled with thriving communities, we must first figure out how to keep a small handful of people alive and healthy for extended periods. This needs to happen in an environment that seems almost deliberately designed to kill anything that isn't perfectly adapted to it. Mars is not a second Earth waiting to be terraformed. It's not a backup plan for humanity. It's a brutal survival test, pushing the limits of human ingenuity and resilience. And the very first step in conquering this challenge is simply staying healthy, maintaining the well-being of the first Martian pioneers. Picking a landing site on Mars is a high-stakes puzzle. It must be flat, safe, and close to water ice, essential for air, water, and fuel. Lower elevations offer slightly more atmospheric protection and easier landings. Sunlight is crucial, making equatorial sites attractive for solar power, but the best spots for resources may also harbor Martian life. Landing humans risks contaminating these regions, complicating the search for native life. Robotic missions must scout and certify sites before humans arrive. The choice isn't just technical, it's ethical, balancing exploration with planetary protection. Where we land will define our relationship with Mars. Rovers are amazing, but to truly understand Mars, we need its rocks on Earth. The Mars Sample Return mission aims to bring back pristine samples for detailed analysis. On Earth, we can search for signs of ancient life and study the hazards of Martian soil. These samples will inform habitat design, spacesuit safety, and resource extraction. They're essential for planning safe human missions. The mission is a critical step, answering scientific questions and assessing risks before people set foot on Mars. The knowledge gained will shape Mars exploration for decades. Bringing Mars to Earth is the safest way to prepare for going there ourselves. The future of human exploration depends on what we learn from these precious rocks. Elon Musk and SpaceX, a powerhouse of innovation and ambition, have set their sights on a goal that was once confined to the realms of science fiction. They're not just dreaming of space travel, they're actively working towards making interplanetary life a reality. They have made Mars colonization a real conversation, pushing the boundaries of what we believe is possible. No longer is it a question of if, but when and how we will establish a permanent foothold on the red planet. His plan, a multifaceted, ambitious undertaking, is to make space travel cheap enough, drastically reducing the cost per launch to make regular missions feasible. This involves streamlining manufacturing processes, developing reusable rocket technology, and optimizing every aspect of space travel. The ultimate goal is to build a city on Mars, a self-sustaining human settlement that can thrive independently of Earth. This Martian metropolis would represent a giant leap for humanity, ensuring our survival as a species. Starship, a fully reusable rocket, is not just a vehicle, it's the cornerstone of this grand vision. It is the centerpiece, the key that unlocks the door to affordable and sustainable space travel. Starship is designed to carry over 100 tons of cargo, a massive payload capacity that dwarfs previous rockets. This allows for the transportation of essential equipment, habitats, and resources needed to establish a Martian base. It can also carry up to 100 people, enough to transport a significant number of colonists, engineers, and scientists to Mars in a single journey. Innovations like in-orbit refueling, where Starship can be refueled in space before embarking on its journey to Mars, and making fuel on Mars, using the planet's resources to produce methane and oxygen for the return trip, are key to the plan, making long-term colonization sustainable and economically viable. As of 2024, Starship is still in testing, undergoing rigorous trials to ensure its safety and reliability. These tests have yielded both spectacular successes and failures, providing valuable data and insights that are crucial for refining the design and operation of the spacecraft. Even if it works flawlessly, the logistics are daunting. A complex web of planning, coordination, and execution that requires meticulous attention to detail. Launch windows open every 26 months when Earth and Mars are in optimal alignment for interplanetary travel, and the journey takes 8 months, exposing the crew to the harsh conditions of space for an extended period. Early settlers must be self-sufficient, capable of surviving and thriving in a hostile environment with limited resources. They must be prepared to be on their own for over 2 years, the time it takes for the next launch window to open. This includes generating power, air, water, food, and fixing anything that breaks, from life support systems to scientific instruments. The timeline for a crewed mission is uncertain, a moving target that depends on technological advancements, funding, and unforeseen challenges. Optimistically, it could happen within a decade, but realistically, it could take much longer, perhaps several decades, to overcome the numerous hurdles that stand in the way. The dream is bold, a testament to human ambition and our innate desire to explore the unknown. But the risks and challenges are enormous, ranging from the dangers of space travel to the difficulties of establishing a self-sustaining colony on a hostile planet. Starship could change everything, revolutionizing space travel and opening up new possibilities for exploration and colonization. But it could also reveal just how hard Mars really is, highlighting the immense challenges that must be overcome to make human life on the red planet a reality. Musk's vision inspires, igniting the imagination and motivating people to push the boundaries of what's possible. But reality will be the ultimate test, determining whether this audacious dream can be transformed into a tangible reality. The first Martian pioneers, those brave souls who venture into the unknown, will be on their own, facing unprecedented challenges and relying on their ingenuity and resilience to survive. They will be far from help, millions of miles away from Earth, pushing the limits of human endurance and paving the way for future generations of Martians. The ultimate dream is to make Mars Earth-like, terraforming it for open-air living. This means thickening the atmosphere, warming the planet, and creating liquid water. But even if we released all the CO2 on Mars, the pressure would still be too low for humans. The energy required is staggering, far beyond our current capabilities. Exotic ideas like orbital mirrors or crashing comets remain science fiction. For now, terraforming is out of reach. Any human presence will be confined to sealed habitats. Mars will remain a world of bubbles, not blue skies, for generations. So, should we go to Mars? Critics argue the money is better spent solving Earth's problems: climate change, poverty, disease. Supporters say Mars is an insurance policy for humanity and a source of inspiration and innovation. The Apollo program transformed science and technology. Mars could do the same. The real value may be in the science and perspective we gain, not in colonization. We should explore with caution and purpose, not as an escape, but to better understand ourselves and our universe. The decision is ours. Is Mars a distraction or destiny? It's a question of dreams versus responsibilities. As we look up at that red light, we must decide what future we want to build. Is the journey to Mars worth it? That answer will shape our next chapter.